I'm so glad you found your way here. Maybe you had a long day, or maybe you're the kind of person who likes falling asleep to deep thoughts and cosmic mysteries, rather than counting sheep. Either way, tonight's journey is for you. You've got nothing to do but rest. Let your mind relax, your breathing slow, and your body grow light, as if gravity itself has softened. Because tonight, we aren't simply stargazing. We're drifting through our home galaxy, the Milky Way, a vast spiral of stars, dust, and dark matter, turning slowly in space for over 13 billion years. But beneath its beauty lie secrets, rogue stars, invisible forces, and ancient remains that defy what we thought we knew. We'll travel gently from its spiral arms to its secretive hidden core, from colossal collisions to stars older than the galaxy itself. You'll hear of black holes and stellar nurseries, and the strange, unfinished story of a galaxy still growing. Some of what you hear tonight may surprise you, or at the very least, spark some curiosity as you drift off to sleep. And just before we begin, if these calm, curious explorations help you unwind or give you a quiet way to end your day, consider liking and subscribing to the channel. It helps others find their way here too, one sleepy soul at a time. Now, let's begin. The Milky Way has already collided with other galaxies, and it will again. Our galaxy may feel like a stable home, but it is built from the wreckage of others. Over billions of years, the Milky Way has absorbed smaller galaxies, drawing them in, unraveling them, and scattering their stars into tidal streams that wrap around the disk. One such galaxy, the Sagittarius dwarf, is being pulled apart right now. And far off in the night sky, Andromeda is drifting slowly closer. In about 4.5 billion years, the two great spirals will merge in a cosmic collision. Stars will almost never hit each other, but the galaxy's shapes will change forever, folding into a new form, vast and quiet. Even galaxies are not eternal. They evolve, collide, and begin again. Some stars in the Milky Way are older than the Milky Way itself. Not every star in the Milky Way was born here. Some halo stars, ancient, metal-poor, and wandering in long, tilted orbits, appear to have formed even before the Milky Way had fully taken shape. Astronomers believe these stars may have originated in smaller, primordial galaxies that merged with our own billions of years ago. Their chemical fingerprints show almost no heavy elements, suggesting they were born shortly after the Big Bang. They move slowly and high above the galactic plane, like elder spirits from a time before spirals, before order. In their light, we glimpse a universe that was younger, wilder, and still learning to become what it is. Our solar system orbits the center of the Milky Way at over 828,000 kilometers per hour. That's more than 230 kilometers every second. And still, it takes about 225 million years to complete just one loop around the galaxy. This path is called a galactic year. In Earth time, we've only gone around the Milky Way about 20 times since the solar system formed. When the first dinosaurs appeared, we were in a different part of the galaxy entirely. The stars we see today weren't always nearby, and won't always remain. Everything is in motion, quietly, slowly, endlessly. Even as we sleep, the Earth turns, the moon circles, and the entire solar system sweeps forward through a galaxy in motion. The galaxy is still growing. Although the Milky Way is ancient, it isn't finished. Even now, it continues to gather material, gas from the intergalactic medium, stars from captured dwarf galaxies, and streams of dark matter that feed its halo. It grows not like a living thing, but like a gravitational structure deepening over time. Some of this growth happens quietly, through infilling clouds. Other times it comes with disruption, as satellite galaxies are torn apart and their stars scattered across the sky. The galaxy you live in today is not the same one the dinosaurs saw, and the one your distant descendants may know could be larger still, stitched from the ruins of 1,000 smaller worlds. We don't know how many arms the Milky Way has. It seems like something we should know, how many arms spiral from the center of our own galaxy. But from our position deep inside the disk, it's hard to see the whole structure. Dust clouds obscure distant regions. Stars blur into one another. For decades, astronomers believed there were 4 major spiral arms. More recent observations suggested maybe fewer, or that the arms twist and split in ways more complex than expected. Some fade into fragments, others wrap around unexpectedly. The Milky Way may not be a neat pinwheel at all, but a living, layered swirl of stars shaped by forces we still don't fully understand. Rogue stars are flung from the core. Most stars drift calmly through the galaxy, but a rare few are flung outward at astonishing speeds, fast enough to escape the Milky Way entirely. These are hypervelocity stars. Some are the remnants of binary systems disrupted by the supermassive black hole at the center of the galaxy. One star falls in and vanishes. The other is slingshotted outward, hurled into the dark at over 1 million kilometers per hour. These rogue stars travel alone, far from the galactic plane, like glowing comets with no return. They remind us that even in a galaxy bound by gravity, there are moments of violent release, quiet expulsions that send stars flying into intergalactic night. The Milky Way and Andromeda are on a collision course. High above the horizon, the Andromeda galaxy appears as a faint blur to the naked eye, a spiral much like our own, lying over 2 million light-years away. And yet, it is moving steadily toward us. In about 4.5 billion years, the Milky Way and Andromeda will collide. It won't be violent in the way you might imagine. Stars are spaced too far apart to crash directly. But their gravity will warp both galaxies into long, stretching arcs. Tidal tails will curl outward. Black holes may spiral together. And after billions of years, the 2 galaxies will merge into a single, larger system. It will be a slow, elegant dance, the future of our home written across the stars. Some stars orbit backward. Most stars in the Milky Way orbit the center in the same general direction. But not all follow the rules. Some stars, especially in the outer halo, move in retrograde, orbiting opposite to the galaxy's main rotation. These stars likely arrived from elsewhere, born in dwarf galaxies that were later absorbed. Their reversed motion is a quiet signature of their foreign origin. It's as if the galaxy carries old memories in its motion, stories of ancient mergers and cosmic encounters, preserved not in light, but in the slow, patient turning of stars against the stream. The Milky Way may have eaten dozens of dwarf galaxies. Over billions of years, the Milky Way has not grown alone. It has consumed. Small galaxies, faint, Lomas companions, have drifted close, been caught in its gravity, and slowly dismantled. Their stars are now part of our halo, disk, or stellar streams. Astronomers have identified several of these mergers by analyzing stellar motion and composition. One especially large event, the Gian-Enceladus merger, added many stars and may have reshaped the early structure of the galaxy. The Milky Way is not a pristine spiral. It is a composite, built from quiet collisions, stitched together from the remains of many smaller worlds. The chemical makeup of stars reveals their origin. Every star carries a unique chemical fingerprint, a pattern of elements imprinted at birth. By studying these signatures, astronomers can trace a star's history. Some stars are rich in heavy elements like iron and calcium, suggesting they formed in dense, metal-rich regions. Others are nearly pure hydrogen and helium, born when the universe was still young. These differences allow scientists to group stars into families, uncover ancient mergers, and reconstruct the hidden story of the Milky Way's formation. In this way, chemistry becomes a kind of time machine, letting us read a star's past like a line of ancient poetry written in light. The sky is full of stellar streams from shredded galaxies. Across the sky, thin ribbons of stars stretch in arcs and curves, barely visible but unmistakable when mapped with precision. These are stellar streams, the remnants of smaller galaxies that wandered too close to the Milky Way and were pulled apart. As they orbit, their stars are smeared across space by tidal forces, forming long, delicate trails that trace their former paths. Some wrap around the galaxy like ghostly halos. Others dive in toward the core. These streams are evidence of past collisions, quiet mergers that built the Milky Way over billions of years. The galaxy, like a tree, carries the rings of its past in every thread of light. The Milky Way is warped. Our galaxy doesn't lie flat like a perfect spiral. Its disk bends upward on one side and downward on the other, forming a graceful wave across the stars. This subtle warp was invisible to us until radio telescopes mapped the hydrogen gas that stretches far beyond the starlight. Astronomers believe the distortion may be caused by satellite galaxies, tugging gently on the Milky Way's edges, or by clumps of dark matter bending the structure from below. Like ripples in a great spinning sheet, the warp reveals that even galaxies are never fully still. Over time, they bend, flex, and change form in response to invisible forces. From a distance, the Milky Way might look like it's dancing slowly through space. You can only see about 0.0000003% of the Milky Way with the naked eye. Under a clear, dark sky, far from cities and streetlights, you might see a few thousand stars. To the human eye, that seems like an ocean of light, but it's barely a droplet. The Milky Way contains over 100 billion stars. Most are hidden from view. Some lie behind thick curtains of dust. Others are too faint or far away for our vision to reach. The pale streak of the Milky Way that crosses the sky on moonless nights is just the innermost whisper of the whole. We live surrounded by a colossal river of starlight, and yet almost all of it remains invisible to us, too vast to grasp from within. Stars orbit the galaxy at different speeds. Unlike planets in a solar system, which follow neat tracks around their star, stars in the Milky Way move with more freedom. Some race ahead in the inner regions. Others drift slowly along the outskirts. This difference in speed, is why spiral arms form. They're not solid structures, but patterns, like slow traffic jams of stars and gas moving through space. As these density waves pass, they trigger new stars to form, lighting up the arms in curls of blue and white. Our own sun is part of this swirl, moving in and out of these patterns across time. The galaxy is not a clock. It is a current, and we are drifting in it. The galaxy holds together because of something we cannot see. By all logic, the Milky Way should not exist. Based on what we can measure, stars, dust, gas, the outer edges of the galaxy are spinning too fast. They should be flung into space, scattered like leaves in a storm. And yet they remain. The answer is dark matter. This mysterious substance does not shine, reflect, or emit any light. But it exerts gravity. And there is so much of it that it outweighs all the visible matter in the galaxy many times over. We don't know what dark matter is, but we know that without it, the Milky Way would fly apart. It is the invisible scaffolding that holds everything in place. There's a supermassive black hole at the core. At the very center of the Milky Way lies an enormous black hole, a singular point of gravity called Sagittarius A*. It is more than 4 million times the mass of the Sun, yet it occupies a space smaller than the orbit of Mercury. We cannot see it directly, but we've watched nearby stars whip around it at tremendous speeds, tracing invisible loops through the void. Sometimes gas and dust fall inward and flare with X-rays as they spiral into the event horizon. For now, Sagittarius A* sleeps, but long ago it may have burned like a quasar, lighting up the galaxy from within. It is the silent conductor of the Milky Way's heart, pulling stars into slow, relentless dance. The Milky Way has a peanut-shaped bulge. When astronomers mapped the center of the galaxy, they discovered something unexpected. The central bulge is not a smooth, round ball of stars, but a three-dimensional peanut shape. Seen from the side, it swells in the middle and narrows at the ends, like a twisting hourglass made of stars. This strange geometry likely formed from the galaxy's central bar, a dense stripe of stars that rotates slowly, buckling and puffing upward over time. These inner structures are sculpted by gravity, billions of years of motion, and the accumulated rhythm of stellar orbits. We live in a spiral galaxy, but its heart is full of complexity, not flat or clean, but intricate and alive. Stellar nurseries shape the spiral arms. The Milky Way's spiral arms are not simply made of stars. They're woven from the birthplaces of stars. Giant clouds of hydrogen, dust, and molecules drift through the galaxy, and when these clouds pass through the spiral arms, they are compressed and set alight with newborn suns. These regions are called stellar nurseries, chaotic, glowing, and full of motion. Ultraviolet light from new stars lights up the clouds, painting the arms with radiant blues and silvers. These bursts of creation trace out the spiral shape, illuminating the curves of the galaxy with quiet fire. Every star, even the sun, was born from one of these cloudy cradles long ago. The Milky Way is surrounded by a vast halo. Beyond the flat spiral disk lies something far more diffuse, a spherical halo that surrounds the entire galaxy. It contains ancient stars, globular clusters, and enormous amounts of dark matter. Though it is nearly invisible, this halo may hold the majority of the Milky Way's mass. Its stars are spread thin across vast distances, orbiting in long, slow arcs that rarely touch the disk. The halo also preserves the remnants of ancient galactic mergers, streams and shells of stars torn from smaller galaxies and left behind like cosmic fossils. It is the galaxy's outer memory, quiet and dim, but still in motion, still shaping what the Milky Way becomes. It contains over 150 globular clusters. Globular clusters are among the oldest objects in the galaxy, compact spheres made of hundreds of thousands of tightly bound stars. They orbit the galactic center in the halo, like moths circling a distant flame. These clusters are incredibly stable, some more than 12 billion years old, and many contain stars that predate the Milky Way itself. Their stars are metal poor, meaning they formed before the universe had time to create many of the heavier elements. They serve as time capsules, holding clues to how the galaxy formed, what it consumed, and what conditions were like in the early cosmos. These quiet, golden spheres drift patiently above and below the galactic plane, glowing in the dark. The galaxy is still growing. Although the Milky Way is ancient, it isn't finished. Even now, it continues to gather material. Gas from the intergalactic medium, stars from captured dwarf galaxies, and streams of dark matter that feed its halo. It grows not like a living thing, but like a gravitational structure deepening over time. Some of this growth happens quietly, through infilling clouds. Other times, it comes with disruption, as satellite galaxies are torn apart and their stars scattered across the sky. The galaxy you live in today is not the same one the dinosaurs saw, and the one your distant descendants may know could be larger still, stitched from the ruins of 1,000 smaller worlds. Rogue stars are flung from the core. Most stars drift calmly through the galaxy, but a rare few are flung outward at astonishing speeds, fast enough to escape the Milky Way entirely. These are hypervelocity stars. Some are the remnants of binary systems disrupted by the supermassive black hole at the center of the galaxy. One star falls in and vanishes. The other is slingshotted outward, hurled into the dark at over 1 million kilometers per hour. These rogue stars travel alone, far from the galactic plane, like glowing comets with no return. They remind us that even in a galaxy bound by gravity, there are moments of violent release, quiet expulsions that send stars flying into intergalactic night. Star formation is slowing down. Long ago, the Milky Way was more active, bursting with fresh stars born from dense, collapsing clouds. But in recent epochs, the pace has slowed. There is still gas available, but much of it is spread thin, heated, or locked in forms that resist collapse. The galaxy is not done making stars, but it is settling. Astronomers estimate that star formation peaked billions of years ago and has been declining ever since. This does not mean the end is near, only that we live in a quieter chapter. A mature spiral, glowing gently in its middle age, still forming stars, but no longer in a hurry. Some stars formed before the Milky Way had a disk. The disk, the broad, flat spiral we think of as the Milky Way, formed gradually over time. But some of the stars in our galaxy are older than the disk itself. These ancient stars reside mostly in the halo or the thick disk, and they formed when the galaxy was still assembling, a loose cloud of stars, gas, and dark matter slowly collapsing inward. By studying their composition and motion, astronomers can peer back into the era before structure, before spirals. These stars are the elders of the galaxy, silent witnesses to its birth and the long, slow shaping of what we now call home. A galactic year is about 225 to 250 million Earth years. As the Sun orbits the center of the Milky Way, it completes one full revolution every few 100 million years. This is called a galactic year, a vast cycle of motion that dwarfs all our calendars. In the time it takes for the Sun to circle the galaxy once, continents drift, species rise and fall, and entire epochs unfold. It is thought that we are currently about halfway through one such orbit. The last time the solar system was in this part of its path, the supercontinent Pangaea had just begun to break apart, and dinosaurs had not yet emerged. A galactic year is the slow heartbeat of cosmic time. The Sun has completed fewer than 25 galactic orbits. In all of its 4.6 billion years of existence, the Sun has only circled the Milky Way around 20 times. That's fewer than you might expect, considering its incredible speed, nearly 830,000 kilometers per hour. But the galaxy is so vast, and the Sun's path so long, that each orbit takes hundreds of millions of years. We often think of the stars as ancient and unmoving, but our solar system is still young on a galactic scale, a newcomer in a city of older, more traveled suns. We are part of the galaxy's motion, but still early in its long, winding story. The Milky Way's rotation defies Newton's predictions. According to Newtonian physics, stars farther from the galactic center should orbit more slowly, just as outer planets move more leisurely around the Sun. But in the Milky Way, stars in the outer regions orbit almost as quickly as those near the center. This defies classical expectations. The reason, astronomers believe, is dark matter, an invisible, unknown form of mass that surrounds the galaxy in a vast halo. Without dark matter, the galaxy would not hold together. With it, the math works. The Milky Way turns like a solid wheel, not because we understand it fully, but because something unseen is holding it in place. The galaxy has enormous molecular clouds. Scattered throughout the Milky Way are vast, dark clouds of cold gas, the raw material of stars. These molecular clouds, composed mostly of hydrogen molecules and traces of dust, can span hundreds of light years across. Within their cold, dense interiors, gravity begins to gather material, forming clumps that collapse into new stars and planets. Some of these clouds are so large and so cold that they absorb visible light entirely, appearing as black patches against the starry sky. They are the galaxy's wombs, quiet, hidden places where the future begins in silence, tucked within curtains of shadow and gas. Supernovae stir the galaxy like storms. When massive stars reach the end of their lives, they explode in cataclysmic supernova, events so powerful they can outshine entire galaxies for a brief moment. These explosions don't just end lives, they create. Shockwaves from supernova ripple through the interstellar medium, compressing nearby clouds and triggering new waves of star formation. They enrich the surrounding space with heavy elements like iron and gold, forged in the heart of the dying star. In this way, supernova act like storms within the galactic ecosystem, stirring, fertilizing, and reshaping everything around them. They are the galaxy's moments of chaos, destructive, radiant, and necessary. Dust hides vast regions of star formation. The Milky Way is full of light we cannot see. Interstellar dust, made of microscopic grains of carbon, silicates, and ice, weaves through the galaxy in clouds and tendrils. Invisible light, it obscures vast regions of space, blotting out stars and entire nebulae. But behind this veil, star formation continues. Infrared telescopes can peer through the dust, revealing glittering nurseries filled with newborn suns. What looks like darkness is often a cradle. The dust, though it hides, is part of the process, absorbing energy, helping gas cool, and shielding delicate stages of stellar birth. What seems like emptiness is often the beginning of something bright. There are starless gas clouds drifting through the galaxy. Not every cloud of gas becomes a star. Across the Milky Way, astronomers have found massive cold clouds that seem destined for collapse, yet remain dark and dormant. Some are too diffuse. Others may be stabilized by magnetic fields or internal turbulence. These starless clouds float through the galaxy like silent possibilities, rich in molecular hydrogen, but untouched by fusion. They may one day ignite, or they may drift until torn apart by external forces, their gas recycled into other regions. In these clouds, the galaxy holds its breath, waiting, perhaps, for the right nudge to spark something new. The Milky Way recycles matter across generations. Stars are not permanent. They live, burn, and die. And in dying, they return their material to the galaxy. Supernovas spread heavy elements. Red giants shed outer layers. Planetary nebulae drift outward into space. This enriched material joins the interstellar medium, where it cools, condenses, and eventually forms new stars, planets, and even life. Every atom in your body has passed through this cycle, born in a star, scattered into space, gathered into new form. The Milky Way is not a static stage, but a great engine of renewal. It breathes in time with its stars, making, unmaking, and beginning again. Metal-polar stars hold clues to the early universe. In astronomy, metals are not just iron or gold, they are any elements heavier than helium. The earliest stars in the universe had almost none of these metals, because they formed before earlier generations of stars had a chance to forge and scatter them. Today, astronomers seek out metal-poor stars in the halo of the Milky Way. These stars, faint and ancient, preserve the chemical conditions of a time long gone. By analyzing their composition, we peer into the primordial past, into the period just after the Big Bang, before galaxies had matured, before the galaxy itself had taken full shape. They are fossils made of light. Some stars wander far from where they were born. A star's birthplace doesn't always define its destiny. Over time, many stars drift away from their natal clouds, pushed by gravitational interactions, orbital resonance, or the slow pull of spiral arms. Some stars are ejected at high speeds, flung across the disk or into the halo. Others migrate gradually, shifting their orbits inward or outward as they spiral through the galaxy. Even our sun is not where it began. Tracing the paths of stars reveals a Milky Way that is anything but static, a galaxy alive with movement, exchange, and quiet dislocation. Home for a star may only be temporary. The galaxy's habitable zone may span tens of thousands of light years. Just as Earth orbits in a Goldilocks zone around the sun, not too hot or cold for life, The Milky Way may have its own galactic habitable zone. This region is thought to lie between the dangerous inner core, full of radiation and gravitational chaos, and the sparse, metal-poor outer edges, where planets may be harder to form. Somewhere in between lies a wide band where conditions are stable, star density is moderate, and elements like carbon, oxygen, and iron are abundant. Earth lies within this zone, one quiet orbit in a vast swirl where life might not be alone in finding a foothold. The spiral arms are not fixed structures. The Milky Way's spiral arms might seem like permanent features, grand, sweeping lines carved into the galaxy's disk. But they are not made of fixed stars. Instead, they are patterns, density waves, that ripple slowly through the disk, compressing gas and triggering new stars as they pass. Stars drift into these arms, shine for a while, and then drift out again. The spiral structure moves at a different speed than the stars themselves, like a traffic jam moving through a highway. From afar, it looks like form and order. From within, it's a pattern of shifting motion, held together by gravity and time, never still, always flowing. The Milky Way hums with cosmic radiation. Beyond visible light, the galaxy glows with more mysterious forms of energy. Cosmic rays, high-energy particles born in supernova and distant galaxies, stream through space and pass through your body every second. X-rays and gamma rays shimmer from dying stars and black holes. Radio waves drift from gas clouds, pulsars, and the cold breath of hydrogen. These invisible hums reveal what light cannot: the violence, magnetism, and ancient fires still flickering within the galaxy's bones. When you look into the night sky, you're only seeing a narrow band of the Milky Way's true spectrum. Beneath the stars, the galaxy hums softly in many colors, many frequencies, a hidden symphony in the dark. There's a giant gamma-ray bubble above and below the core, stretching tens of thousands of light-years above and below the galactic center, are two vast, ghostly lobes of high-energy light, the Fermi bubbles. Discovered only recently, they glow in gamma rays, extending like twin balloons from the Milky Way's heart. No one is entirely sure what caused them. They may be the remnants of a long-ago outburst from the central black hole, or the mark of fierce star formation that once flared through the core. Either way, these enormous structures drift silently over the galaxy, invisible to human eyes. They are reminders that the Milky Way has a past we cannot fully see, echoes of violence wrapped in radiance, far above the stars we know. We live in a minor spur between major arms. Our solar system doesn't lie in one of the Milky Way's grand spiral arms. Instead, we occupy a small structure called the Orion Spur, a relatively quiet lane of stars nestled between the larger Sagittarius and Perseus' arms. It's not especially dense, nor especially active, but that may be why we're here. In the calm between galactic highways, massive supernova are rarer, radiation storms less frequent. This quiet corner may have given life on Earth the time it needed to emerge and evolve. From the outskirts, the galaxy seems dramatic and radiant. But in this quiet spur, we've found just enough peace for complexity to unfold. The Milky Way has a bar-shaped center. When astronomers look toward the galactic core in infrared light, they see not a perfect circle, but a thick, elongated bar of stars crossing the middle, a kind of glowing bridge. This bar rotates slowly, and its gravitational pull shapes the inner spiral arms. Bars like this are common in spiral galaxies. They form when stars in the disk begin to drift inward and pile up along a central axis. Over time, the bar becomes a stable structure, stirring gas, triggering new stars, and feeding material toward the black hole at the center. It is not just a shape, but a dynamic engine, sculpting the galaxy's heart from within. It's part of a larger structure called the local group. The Milky Way doesn't exist in isolation. It belongs to a collection of more than 50 galaxies known as the local group, a small cluster drifting together through space. The two largest members are the Milky Way and Andromeda, each with its own family of satellite galaxies. Scattered around them are smaller dwarfs, faint ellipticals, and star-poor galaxies made almost entirely of dark matter. The local group spans more than 10 million light-years, and it is bound together not by proximity alone, but by gravity. We are part of the family, quiet, widely spaced, but still linked by the invisible threads of shared motion and mutual pull. Galaxies in the local group are gravitationally bound. Despite their vast separations, the galaxies of the local group are not drifting apart. In fact, many are moving slowly toward one another. Gravity holds them in a kind of slow-motion ballet, curving their paths across millions of years. Some of the smallest galaxies orbit the Milky Way like moons, looping and falling, dissolving into streams. Others drift independently, but remain tethered, caught in a web of shared motion. Over time, this group may condense. Galaxies may merge, fade, or be absorbed. It's not a static arrangement, but a gentle gathering of cosmic islands, a family drawn closer by time, inertia, and the long reach of gravity. The galaxy's disk has a thick and thin component. The Milky Way's disk looks flat from a distance, but up close, it's layered. The thin disk is where we live, a wide, dense plain filled with young stars, open clusters, and star-forming gas. But above and below it lies the thick disk, older, puffier, and more diffuse. Stars in the thick disk tend to be older, with fewer heavy elements. They move in orbits that are more tilted and elliptical, suggesting they formed under different conditions or were stirred by early galactic collisions. The galaxy's disk is not uniform. It's textured, layered, and shaped by time, like sediment settled on the floor of a cosmic ocean. The galaxy's magnetic field threads through the disk. Though invisible to the eye, the Milky Way is laced with a vast magnetic field, stretching across the disk, rising into the halo, and weaving through the interstellar medium. This field is weak by earthly standards, but over galactic distances, it shapes how cosmic rays travel, how gas clouds collapse, and how matter flows through space. It aligns with spiral arms, forms arcs above the plane, and twists into loops that defy simple explanation. Studying it requires radio telescopes and careful analysis, but its presence is unmistakable. The Milky Way does not just glow with light. It breathes with magnetism, a subtle pulse running through its bones. The interstellar medium is full of invisible structures. Between the stars lies more than emptiness. The interstellar medium, a thin blend of gas, dust, and plasma, weaves its way through the Milky Way like a fog. To the naked eye, it is mostly invisible. But when viewed with radio and infrared telescopes, it reveals a stunning complexity. It forms filaments, bubbles, shock waves, and cold, dense clouds where stars are born. Supernovae carve vast cavities in it. Stellar winds sculpt it into shapes that ripple across light years. The space between stars is not a void, but a shifting web of matter and magnetism, the quiet fabric from which galaxies evolve and life eventually begins. Cosmic rays constantly pass through us from the galaxy. Every second, high-energy particles, mostly protons and atomic nuclei, stream through your body, launched long ago by exploding stars. These are cosmic rays, and they are everywhere. They travel close to the speed of light, bending through magnetic fields, bouncing off clouds, and occasionally colliding with atoms in Earth's atmosphere, where they create showers of secondary particles. Most of the time, we don't notice them, but they carry stories from across the galaxy, evidence of ancient supernova, traces of distant acceleration, messages from the violent hearts of stars. Even as you rest, the galaxy is whispering, in particles, in silence, in lightless rays. The galaxy is not symmetrical. Though many diagrams show it as a neat, even spiral, the Milky Way is not perfectly balanced. One side of the disk appears thicker. Some spiral arms are brighter, longer, or more curved than others. The warp in the outer disk is lopsided. Even the star counts between hemispheres are slightly off. These asymmetries may be caused by gravitational encounters, past mergers, or the influence of dark matter. They remind us that galaxies, like living things, carry traces of their histories in their shapes, scars of collisions, wrinkles of time, and quirks of uneven growth that give them character and depth. The oldest known star may live in our halo. High above the galactic plane, drifting through the halo, astronomers discovered a star that may be nearly as old as the universe itself. It contains almost no heavy elements, a signature of stars born soon after the Big Bang, before generations of supernovae enriched the cosmos. It likely formed over 13 billion years ago, long before the Milky Way was fully formed. It burns quietly now, with a soft red glow, low in mass, but rich in history. It is not just a star. It is a time capsule, a living relic from the universe's earliest dawn. The center of the galaxy spins faster than the outskirts in the inner regions of the Milky Way. Stars orbit the center much more rapidly than those farther out. Near the core, the gravitational pull is stronger, packed with mass from stars, dust, and the supermassive black hole Sagittarius A*. This causes stars to sweep through tighter, faster orbits, completing revolutions in just a few million years. Out in the suburbs of the galaxy, like where our sun lives, stars orbit more slowly, taking hundreds of millions of years. This uneven rotation creates twisting patterns, stretches spiral arms, and keeps the disk from behaving like a solid structure. The galaxy moves like a great wheel, but one whose rim lags behind its core. Spiral arms are shaped by density waves. The spiral arms of the Milky Way are not fixed trails of stars. They are patterns formed by waves of higher density moving through the galactic disk. As gas and dust pass through these waves, they are compressed, triggering star formation and lighting up the arms with bright young stars. These stars eventually drift out of the wave, while new ones form behind them, creating a self-sustaining illusion of structure. Like ripples in a pond or traffic comping on a highway, the arms are dynamic, always in motion. From a distance, they appear still. From within, they are a dance of matter and rhythm, shaped by gravity and time. Stars are born from cold, collapsing gas. In the dark arms of the Milky Way, star formation begins in silence. Massive clouds of molecular hydrogen, sometimes hundreds of light years wide, drift through space, chilled to just a few degrees above absolute zero. Within these clouds, gravity slowly takes hold. Small regions grow denser and begin to collapse under their own weight. As the gas falls inward, it heats, spins, and flattens, forming a protostar at the center. Over time, the pressure and temperature grow until nuclear fusion ignites and a new star is born. From the coldest shadows come the brightest lights, spun gently into being by the quiet force of gravity. Star clusters can dissolve into the galactic field. Many stars are born not in isolation, but in groups, tight clusters formed from the same collapsing gas cloud. These clusters, bound by mutual gravity, drift together for millions or even billions of years. But over time, they begin to scatter. Tidal forces from the Milky Way's mass, close encounters with other stars, and internal dynamics all work to pull clusters apart. Stars peel away one by one until the cluster fades into the general star field of the galaxy. Even our Sun was likely born in a stellar cluster long ago, its siblings now scattered, dimmed, or lost in the haze of distance. The galaxy contains ancient hypermetal-poor stars. Among the rarest and most precious objects in the Milky Way are hypermetal-poor stars. Stars whose atmospheres contain almost no elements heavier than helium. Some of these contain less than 1/10,000th the iron found in the Sun. These stars are believed to be among the first born after the very first supernova, carrying only faint traces of enrichment from a universe still forming itself. They are incredibly old, incredibly pure, and scattered in the halo like distant lanterns from the dawn of time. Each one is a kind of relic, a glowing, gravitationally bound signature from a near-forgotten epoch. Planetary systems form throughout the Milky Way. Planets are not a rare feature of the cosmos. They are a natural consequence of star formation. As a new star ignites, a rotating disk of leftover gas and dust surrounds it. Within this disk, particles stick together, gather mass, and grow into worlds. Across the Milky Way, planetary systems are common. Some are vast, with gas giants and frozen moons. Others are compact, with rocky planets hugging close to dim stars. Some may resemble our own, while others defy our expectations entirely. The galaxy is not just full of stars. It is full of systems, solar families, each one with its own unique balance, orbit, and potential. Earth is near the co-rotation radius. In the Milky Way, the spiral arms rotate at a different speed than individual stars, like a moving pattern rather than a solid structure. But there is a special distance from the center, called the co-rotation radius, where the average speed of stars matches the rotation speed of the spiral arms themselves. Earth's Sun orbits close to this boundary. This gentle match in motion may help us avoid frequent crossings of spiral arms, places with higher star density, more supernova, and gravitational disturbances. We live, quite possibly, in a more stable neighborhood of the galaxy, shielded not by walls, but by resonance. The Sun bobs up and down through the galactic plane. As it orbits the Milky Way, the Sun doesn't follow a perfectly flat path. Instead, it moves in a gentle wave, drifting above and below the galactic plane like a cork in slow motion, rising and falling over tens of millions of years. This vertical oscillation is caused by the gravitational tug of the galaxy's mass, pulling and releasing the solar system as it moves. Some researchers have even wondered whether this motion might influence cycles of extinction on Earth, though the evidence is not yet clear. Still, it's a reminder. Even on its steady path around the center, the sun is not gliding, it's swaying softly through space. We don't know what dark matter is, but we know it's there. Dark matter makes up most of the Milky Way's mass, yet it has never been seen directly. It does not emit or absorb light. It passes through ordinary matter as if it weren't there. But its gravitational effects are unmistakable. It holds the galaxy together, explains the unexpected rotation speeds of stars, and shapes the formation of large-scale cosmic structures. Without it, the Milky Way would fly apart. Astronomers detect it not by seeing it, but by watching how it moves other things. It is the galaxy's hidden scaffolding, invisible, silent, and still one of the greatest mysteries in science. There's more mass outside the disk than inside. Most of the Milky Way's visible stars lie within the flat, luminous disk, but the majority of its mass resides elsewhere. The galaxy is surrounded by an enormous dark matter halo, extending far beyond the furthest stars. This halo holds the galaxy together, outweighing the disk by a large margin. It is populated sparsely with ancient stars and globular clusters, but its true bulk is unseen. When we think of the Milky Way, we picture its spiral arms and starry plane. But that's only the glowing surface. The mass that defines the galaxy, its gravity, its motion, its reach, is mostly hidden, enveloping everything like a quiet shroud. The Milky Way's core may have flared as a quasar. Today, the heart of our galaxy appears quiet. But there is evidence that it was once dramatically more active. The presence of huge gamma-ray structures like the Fermi bubbles and traces of high-energy light reflected in surrounding clouds suggest that the supermassive black hole at the center may have once flared as a quasar, a brilliant, violent beacon fueled by infilling matter. Quasars are among the brightest objects in the universe, outshining entire galaxies. If the Milky Way once burned like this, it would have looked dramatically different, a spiral wrapped around a blinding heart of light. That time has passed, but the echoes remain. The galaxy's structure changes over billions of years. Galaxies may look timeless, but they are always evolving. Spiral arms shift. Bars form and dissolve. Gas flows inward and outward. Stars are born and die, leaving behind a changing population. Even the shape of the Milky Way's disk, warped, rippling, and lopsided, is slowly altering. Encounters with dwarf galaxies and dark matter can bend or twist the structure. Over billions of years, the galaxy's silhouette has shifted like a drifting cloud. The Milky Way of today is not the one that was, and not the one that will be. Its beauty lies not in permanence, but in quiet transformation. Gravitational waves ripple through the galaxy from distant mergers. All across the universe, massive objects collide, black holes spiral together, neutron stars crash, and entire galaxies merge. These events send out gravitational waves, ripples in the fabric of space-time itself. Though faint, some of these waves pass through the Milky Way, distorting space by tiny amounts as they travel. They are incredibly difficult to detect, but observatories like LIGO and Virgo have already captured several. New experiments aim to detect the background hum of gravitational waves that fills the cosmos. Even now, as you rest, space itself is shifting. Not enough to feel, but enough to tell us that somewhere far away, the universe is changing. Some stars orbit in elongated, tilted paths. Not all stars move in neat circles around the galactic center. Some follow long, stretched ellipses, their paths looping high above and far below the disk, tilted at odd angles from the main plane. These stars likely come from different origins, relics of dwarf galaxies swallowed by the Milky Way, or survivors of ancient gravitational upheavals. Their orbits are clues, three-dimensional maps of the galaxy's chaotic past. By tracing their motion, astronomers reconstruct the invisible architecture of the Milky Way's mass and memory. These stars drift like messengers from disrupted systems, tilted, stretched, but still bound to the whole. The Milky Way emits neutrinos we can barely detect every second. Trillions of neutrinos pass through your body, straight from the stars. These ghostly particles are produced in nuclear reactions from the sun, from supernova, and from cosmic rays striking atoms in space. The Milky Way is bathed in them. Yet they are so light, so unreactive, that they slip through almost everything, leaving no trace. Special observatories, buried deep underground or under ice, try to catch just a few flashes of light from a rare collision. Neutrinos carry information from places we cannot see, from stellar cores, collapsing giants, and the galaxy's unseen energy. They are the whispers of cosmic fire. Interstellar space isn't empty, it's a turbulent sea. Between the stars, space is not smooth or still. The interstellar medium, thin clouds of gas and dust, is stirred by shock waves, magnetic fields, and the motion of stars. Temperature can vary wildly. Flows of material collide, mix, and fragment. Clouds stretch, fold, and tumble. On large scales, this creates a kind of turbulence, like a slow-motion ocean swirling through the disk. Star formation, cosmic rays, and even galactic evolution are all affected by this restless sea. What looks from afar like calm starlight is, up close, a dynamic, rippling fabric, shaped by invisible winds and ancient energy. The galactic halo may contain rogue planets. Planets are not always tethered to stars. Some fall normally and are later ejected from their systems. Others may never have had a star at all. These are rogue planets, worlds adrift in the galaxy, cold, dark, and alone. Though difficult to detect, studies suggest that there may be billions of them in the Milky Way, some even in the outer halo, where stars are few and far between. Without light or warmth, they float unseen, warmed only by internal heat. They are orphans of the galaxy, planetary drifters following long, lonely paths through the darkness between stars. Magnetic fields shape the flow of cosmic dust. Interstellar dust, tiny grains of carbon and silicate, moves not just under gravity, but also under the influence of the galaxy's magnetic field. These fields thread through the Milky Way like invisible currents, guiding the motion of charged particles and influencing how gas and dust align. In some regions, dust grains spin rapidly, emitting faint microwave light. In others, they align with magnetic lines, polarizing the starlight that passes through them. Understanding these effects helps astronomers trace the magnetic field structure and even remove its influence from cosmic background studies. Dust is not passive. It dances to a magnetic rhythm, following hidden patterns in the dark. Some stars are enriched by neutron-star collisions. When two neutron stars spiral together and collide, they create one of the most violent events in the universe, a kilonova. In this brief, blinding explosion, enormous quantities of heavy elements are forged: gold, platinum, uranium, and more. These materials are cast into space, mixing with gas and eventually forming new stars. Some stars in the Milky Way carry the chemical fingerprints of these rare events, enriched in elements that could only have come from such collisions. They are not just luminous bodies, but record keepers of ancient cataclysms, burning with the residue of stellar wreckage and cosmic alchemy. The Milky Way may have a hidden bar within a bar. At the heart of the galaxy lies a bar of stars, an elongated bridge of light crossing the central bulge. But deep within that bar, astronomers have found hints of another, smaller bar, tilted at a different angle, rotating independently. This inner structure is difficult to see directly, obscured by dust and distance, but its gravitational influence appears in the motion of nearby stars and gas. Bars like this may help funnel material toward the supermassive black hole, feeding it and shaping the dynamics of the core. The Milky Way's center is not one simple shape. It's a layered, shifting labyrinth of light and motion. Gas inflows feed the galaxy from the cosmic web. The Milky Way is not a closed system. It draws in fresh gas from the intergalactic medium, long, tenuous streams flowing through the vast cosmic web. These inflows provide the raw material for new stars, replenishing what the galaxy loses over time. Some gas arrives as cold filaments, slipping quietly into the disk. Other streams fall in hotter, shock-heated forms, lighting up in ultraviolet or X-ray light. These invisible rivers sustain the galaxy's growth and evolution, linking it to the larger universe beyond. Even now, the Milky Way drinks from distant reservoirs, nourished by threads of matter spun from the early cosmos. Hot gas bubbles form chimneys out of the disk. When clusters of massive stars go supernova, they create enormous cavities in the interstellar medium. These can join together into superbubbles, vast pockets of hot gas that punch upward through the galactic disk and vent into the halo. The result is a kind of chimney, a channel where energy, gas, and magnetic fields escape from the plane of the galaxy. These chimneys regulate the pressure of the interstellar medium, redistribute metals, and help shape the halo's structure. The galaxy, in this way, breathes, not just within the disk, but through towering columns that carry its energy up and out into the dark. The galaxy shines in X-rays from old stars and black holes. Though the Milky Way appears calm in visible light, it glows fiercely in other wavelengths. X-rays pour from its core, from collapsed stars, and from the edges of black holes. White dwarfs and neutron stars in binary systems can siphon matter from companions, heating it to millions of degrees. Hot gas in the halo also emits faint X-rays, revealing the galaxy's larger skeleton. We cannot see this high-energy light with our eyes, but telescopes like Chandra and XMM Newton paint a very different portrait of the galaxy, not a tranquil spiral, but a realm of extreme temperatures, compact remnants, and hidden radiation. Pulsars act as cosmic clocks throughout the Milky Way. When a massive star dies and collapses into a neutron star, it may be left spinning, fast and precise, with beams of radiation sweeping across space. These are pulsars, and some rotate hundreds of times per second, pulsing in regular, measurable rhythms. They are so consistent that astronomers use them as cosmic timekeepers, tracking their signals to measure distances, test gravity, and even search for gravitational waves. Across the Milky Way, pulsars blink quietly, remnants of death, but also beacons of astonishing order. They keep time not for minutes or days, but for entire epochs, ticking steadily in the silence between stars. Radio waves map the hidden structure of the galaxy. Much of the Milky Way is invisible in visible light, hidden by dust, distance, or faintness. But radio waves can slip through these barriers, revealing structures otherwise unseen. They trace cold hydrogen gas, outline magnetic fields, and highlight emissions from pulsars, supernova remnants, and even distant quasars beyond the galaxy. Using arrays of radio telescopes, astronomers have mapped the spiral arms, measured the warp of the disk, and discovered star-forming regions cloaked in darkness. Where light is blocked, radio soundings let us see. The galaxy speaks in a language we can't hear, but one that science has learned to translate into shape and shadow. The Sun was likely born in a stellar cluster. Stars rarely form in solitude. They are usually born in groups, stellar clusters shaped from the same collapsing cloud of gas and dust. Our Sun was almost certainly one of these. Long ago, it shared space with hundreds, perhaps thousands, of sibling stars, all born in the same cradle. Over time, gravitational tides, passing stars, and the motion of the galaxies scattered the cluster. Most of the Sun's siblings have wandered far, flung into different orbits, carrying with them fragments of our shared past. Some may still shine nearby, invisible among the stars, lost family in a sea of light. The Sun's siblings are scattered across the galaxy. Though the Sun's birth cluster has long since dissolved, astronomers are searching for its lost siblings, stars that share its age, motion, and chemical fingerprint. Using vast surveys like Gaia and spectroscopic databases, researchers hope to identify these long-lost relatives. A few candidates have emerged, stars that may have shared our origin, formed from the same cloud of enriched gas. If found, they could reveal details about the conditions in which the Sun and the early solar system were born. Our place in the galaxy is not entirely solitary. Somewhere out there, the Sun's ancient kin may still shine. The galactic disk wobbles as it spins. The Milky Way's disk is not perfectly flat. It wobbles, gently rippling like a spinning plate nudged off balance. This warp is most visible in the outer regions, where the disk bends upward on one side and downward on the other. It may be caused by the gravitational influence of nearby dwarf galaxies, interactions with dark matter, or internal asymmetries. The wobble rotates slowly, like a vast wave moving through the stars. From Earth, we don't feel it. But from afar, the Milky Way is not a pristine spiral. It is a breathing, undulating sheet of stars, curving gently as it turns. Galactic tides can distort star clusters and streams. Just as the Moon's gravity pulls tides on Earth, the immense mass of the Milky Way exerts tidal forces on everything within it. Star clusters, satellite galaxies, and even globular groups feel the galaxy's uneven gravitational pull. Over time, these tides can stretch and distort them, drawing out long stellar streams or peeling stars away from their orbits. Many of the faint arcs of stars mapped across the sky are remnants of such encounters. Clusters in the process of being unraveled, galaxies slowly torn apart. The galaxy doesn't break these structures suddenly. It unravels them patiently, strand by strand, over millions of years. The Milky Way's mass is still uncertain. You might think we would know the mass of our own galaxy, but measuring it is remarkably difficult. Stars and gas make up only a small portion of the total. The rest lies in the vast dark matter halo, which we cannot see directly. Estimates vary. Some suggest a mass close to 1 trillion times that of the Sun. Others place it much higher. The uncertainty comes from trying to measure how fast stars orbit at great distances, a task clouded by limited data and the influence of invisible matter. The Milky Way is our home, but its weight remains a quiet mystery. It may be heavier than Andromeda. For many years, astronomers assumed that the Andromeda galaxy, slightly larger and brighter than the Milky Way, was also more massive. But recent measurements suggest that the Milky Way's dark matter halo may be broader and denser than previously believed. If that's true, our galaxy could outweigh Andromeda, despite its more modest appearance. This matters not only for comparisons, but for predictions. When the two galaxies eventually merge, their relative masses will shape the encounter's dynamics. The Milky Way may look gentle, but beneath its quiet spiral arms, it carries more weight than we once imagined. The Magellanic Clouds may be on their first orbit. The Large and Small Magellanic Clouds, two bright satellite galaxies visible from the southern hemisphere, have long been thought to orbit the Milky Way. But new evidence suggests they may be newcomers, captured only recently in cosmic terms. Their velocity and motion through space hint that this could be their first close pass. If true, they're not long-standing companions, but distant wanderers just now falling under the Milky Way's pull. Their arrival has stirred the outer disk and warped the galaxy's shape, as if the Milky Way is responding to a new gravitational guest. The sky's quiet is full of first encounters. The Magellanic Stream is a ribbon of stripped gas. Trailing behind the Magellanic Clouds is a vast ribbon of hydrogen gas, a structure called the Magellanic Stream. It stretches over hundreds of thousands of light years, wrapped in curves and arcs across the southern sky. This stream was pulled away by tidal forces as the dwarf galaxies passed close to one another and to the Milky Way. Invisible light, it reveals itself in radio wavelengths, a long trailing whisper of motion and loss. The stream may one day feed new star formation in the Milky Way, or settle into the halo like a thread of memory stretching between galaxies. Some gas clouds orbit in polar directions. Not everything in the Milky Way follows the neat plane of the disk. Some clouds of gas, and even some stars, move in highly inclined orbits, passing above and below the galaxy's main structure. These polar orbits likely come from past mergers, when dwarf galaxies or stray clouds were captured at odd angles. Over time, they'd continued to orbit on tilted paths, like comets around a planet. These misaligned orbits are records of disruption, visible reminders that the galaxy is not a closed system, but an evolving structure, shaped by the unpredictable flow of cosmic history. Giant shells of gas surround past starbursts. In several regions of the Milky Way, astronomers have found enormous spherical shells of gas, some spanning hundreds of light years. These shells are the remnants of powerful starbursts, episodes when clusters of massive stars formed together, lived brief lives, and exploded in rapid succession. Their combined winds and supernova carved out huge cavities in the interstellar medium, blowing gas outward in all directions. Over time, the expansion slows, but the shells remain, ghostly bubbles marking where the galaxy once burned bright with stellar birth and death. These are the fossils of cosmic fireworks, still echoing in the cold. Stars occasionally collide in dense regions. Space is vast, and stars are small. But in the densest regions of the Milky Way, such as the cores of globular clusters, stars can pass close enough to interact and even collide. When they do, the result can be dramatic. A burst of light, the merging of two suns, or the formation of a rare blue straggler star, one that appears younger than its neighbors. These collisions are rare but not impossible. Over billions of years, the tightest stellar neighborhoods can rearrange themselves through gravity and chance. In these crowded stellar cities, time moves differently, and space is never quite empty. Binary stars can be torn apart by tidal forces. Many stars live in pairs, orbiting each other in gravitational embrace. But even this bond can be broken. If a binary system passes close to the Milky Way's central black hole, or through a dense cluster, tidal forces can disrupt their orbit, flinging one star away, while the other is captured or slowed. In some cases, a companion is hurled out of the galaxy entirely, becoming a rogue star speeding through intergalactic space. These stellar breakups happen silently, in places we rarely see, a quiet tearing of ancient partnerships by gravities in different hand. Some stars escape the galaxy entirely. Most stars are gravitationally bound to the Milky Way. But occasionally, a star reaches escape velocity, over 500 kilometers per second, and is flung outward, never to return. These hypervelocity stars are rare, but real. Some are thought to be ejected by interactions with the supermassive black hole at the galaxy's center. Others may be slingshotted by three-body encounters or supernova in binary systems. Once free, they travel alone into intergalactic space, tiny lighthouses drifting far beyond the spiral's edge. They carry the galaxy's memory outward, becoming solitary pilgrims in the great dark between galaxies. The Milky Way contains stars through other galaxies. Not all stars within the Milky Way were born here. Some may have originated in other galaxies, captured during mergers or flung into our halo from distant regions of the local group. These intergalactic wanderers often move on unusual orbits, far from the disk, tracing paths through the outskirts or halo. They can be identified by their composition or motion, stars that don't quite fit the local patterns. Like cosmic immigrants, they bring stories from other environments, other histories, other skies. The Milky Way is not a sealed system. It is a living mosaic, slowly stitched together by time and motion, as a fountain of gas cycling between the disk and halo. Above and below the Milky Way's bright disk, gas rises and falls in a quiet loop known as the galactic fountain. Supernova and stellar winds heat and eject material upward into the halo, where it cools, condenses, and gently rains back down over millions of years. This cycle stirs the interstellar medium, redistributes heavy elements, and helps regulate star formation. It's a quiet respiration, a breathing motion of matter between the dense plane and the vast halo. The galaxy, in this way, doesn't just spin. It circulates, it exhales and inhales, keeping its structure in motion across immense spans of time. The galaxy's dust grains carry organic compounds. Within the clouds of interstellar dust that drift between stars, scientists have detected complex organic molecules, carbon-based compounds that form the raw ingredients for life. These include polycyclic aromatic hydrocarbons, simple sugars, alcohols, and more. Though not alive, they are chemically rich, formed in the atmospheres of dying stars or within cold clouds shaped by radiation. These tiny grains, carried across light years by galactic winds, settle into the gas that forms stars and planets. Some may have fallen onto the early Earth. The galaxy's dust is not just debris, it is a cargo of potential, drifting silently through the dark. Interstellar clouds may seed solar systems with ingredients for life. The birthplaces of stars are also the birthplaces of worlds. As planetary systems form from collapsing clouds of gas and dust, they inherit the chemical fingerprints of their parent nebulae. If that cloud contains water, carbon compounds, and other building blocks of biology, those ingredients may end up in comets, asteroids, or planets. Some regions of the Milky Way are especially rich in such prebiotic chemistry. We don't yet know how common life is, but the conditions for it seem to arise naturally. The seeds of life may be scattered far and wide, tucked into the galaxy's coldest cradles, waiting for a place to grow. Some stars rotate hundreds of times faster than the Sun. Most stars spin, but some spin incredibly fast, completing a full rotation in just a few hours. These rapid rotators are often young, massive, and unstable, with equators that bulge from centrifugal force. A few reach such high speeds that they fling off material, forming glowing disks around themselves. The Sun rotates once every 25 to 35 days, depending on latitude. But these fast-spinning stars rotate hundreds of times more quickly, approaching physical limits. Their internal structures and evolutionary paths are different. Their lives may be brief, but while they last, they spin like sirens in the dark. The galaxy is tilted relative to the ecliptic. From Earth, the Milky Way arcs across the night sky in a graceful band of light. But it doesn't align with the plane of our solar system. The galactic plane, the flat disk in which most of the galaxy's stars reside, is tilted about 60 degrees relative to the ecliptic, the path traced by the Sun and planets. This tilt is why the Milky Way rises at an angle and why it shifts position with the seasons. We are part of the galaxy, but our own little system is angled slightly askew, a small, tilted boat drifting through a larger, spinning sea of stars. Some stellar remnants are older than the galaxy's disk. Among the faint stars in the halo, astronomers have found white dwarfs, the cooling cores of once luminous stars that are older than the Milky Way's thin disk itself. These ancient remnants formed when the galaxy was young, before its main structure had fully settled. Their existence hints at an earlier time of star formation, a deeper history etched into the outer halo. They have burned for billions of years, slowly fading, carrying with them the quiet residue of a time when the Milky Way was still gathering its shape. The disk may be bright, but the halo remembers further back. The farthest stars orbit well beyond the main structure. The Milky Way's most distant stars orbit far beyond the familiar spiral arms, tens or even hundreds of thousands of light-years from the center. These stars move through the galactic halo on slow, wide paths, taking billions of years to complete a single orbit. Many were likely captured from smaller galaxies in past mergers, now drifting in the outermost reaches like distant sentinels. They are faint, sparse, and far between, but they help define the galaxy's size, shape, and gravitational influence. The Milky Way is not just what we see. It extends deep into the dark, shaped by wanderers at its edge. The Milky Way's shape is lopsided in several ways. Though often pictured as a symmetric spiral, the Milky Way is subtly lopsided. One side of the disk is thicker than the other. The spiral arms are uneven in brightness and extent. Even the stellar halo is slightly off-center. These asymmetries likely arise from gravitational interactions with the Magellanic Clouds, with dark matter clumps, or with past mergers. The galaxy is not a perfect pinwheel. It is a living structure, marked by tugs and twists, like a spinning dancer whose skirt has been caught by the wind. Its beauty lies in that irregularity, a graceful imbalance sculpted by time. Astronomers map the galaxy using variable stars. Certain stars pulse in brightness over regular intervals, expanding and contracting like slow, luminous heartbeats. These are variable stars, and some types like Cepheids and Ara Lyrae have well-known relationships between their brightness and their pulse period. By measuring how long a star takes to brighten and dim, astronomers can determine its true luminosity, and by comparing that to how bright it appears, its distance. These stars serve as cosmic yardsticks, helping us map the shape, structure, and scale of the Milky Way. They are lights that measure the dark, blinking beacons scattered through the spiral. The Gaia mission is revolutionizing our understanding of the Milky Way. Launched by the European Space Agency, the Gaia spacecraft is creating the most precise map of the Milky Way ever made. By measuring the positions, motions, and brightness of over 2 billion stars, Gaia reveals the galaxy's three-dimensional structure and its motion through time. It has uncovered streams from shredded galaxies, mapped the warp of the disk, and traced the Sun's orbit with exquisite detail. With each new data release, Gaia deepens our understanding, turning a hazy smear of stars into a sharp, living map. It is astronomy's most ambitious star chart, a quiet revolution unfolding among the stars. The galactic plane marks a dense path of stars. If you look up on a dark night, away from city lights, you may see a hazy river of starlight crossing the sky. That's the galactic plane, the thickest slice of the Milky Way's disk. It's not a line, but a depth, a vast, flattened band where the majority of the galaxy's stars reside. Through this plane, stars are densely packed, dust is layered, and star formation is common. From our vantage point, we're looking along the grain of the galaxy, peering through its richest corridors. This band isn't just beautiful, it's the crowded, humming heart of where most stars live and die. The night sky is brightest toward the galactic center. The core of the Milky Way lies in the direction of the constellation Sagittarius, a rich, glowing concentration of stars, dust, and unseen mass. From Earth, we can't see the very center in visible light. Dust clouds obscure our view, but the area glows with brightness in infrared and radio. Even with the naked eye, the region appears more crowded, more luminous, filled with the overlapping light of billions of stars. We orbit far from this center, in a quiet suburb of the galactic disk. But when we look inward, we glimpse the crowded city at the galaxy's heart. We see the Milky Way John from Earth. Because we live within it, We cannot look down on the Milky Way from above. Instead, we see it from the inside, a flat ribbon of stars stretching across the sky, curved only by the horizon. This John view compresses the galaxy into a single arc, making it hard to grasp its full structure from our perspective. It took centuries of observation, cataloging, and mathematical deduction to realize the spiral we belong to. From Earth, we gaze through its disk, like standing in a forest and looking along the line of the trees. We do not see the shape we're part of, only the vastness that surrounds us. The galaxy holds far more than we can ever possibly see. Even with our most sensitive instruments, we glimpse only a fraction of what the Milky Way contains. Light is blocked by dust. Motion is hidden in silence. Dark matter outnumbers luminous stars. Between every star lies emptiness, and within every empty space, potential. The Milky Way is not just what we see, it is what we suspect, what we infer, what we long to understand. It holds ancient light, future stars, drifting worlds, and questions still without answers. And within that vastness, somehow we find ourselves, one planet among many, orbiting a quiet star, floating through a story too wide for the eye. And now, the stars begin to dim behind your thoughts. We've drifted through 100 quiet truths, from the warp of the galaxy's disk to the farthest halo stars, from newborn suns to long-dead remnants, from dust and gas to light and shadow and everything in between. You've wandered through stellar nurseries, danced along spiral arms, and gazed toward the galactic heart, glowing behind curtains of dust. You are a part of this galaxy, not just a passenger on Earth, but a participant in its long and luminous unfolding. The iron in your blood was forged in stars. The oxygen you breathe was sculpted in ancient explosions. The atoms of your body trace their lineage to the earliest times, born from the same matter that now fuels suns and whispers through clouds of interstellar dust. Tonight, as you rest, the galaxy turns on. Stars are forming. Light is traveling. Silent orbits continue. And you are floating within it, a small warmth in the dark, resting in the spiral arm of a quiet, radiant sea. If you happen to still be awake, you can go ahead and watch the next chapter now. I hope you sleep well and dream softly. Good night.